Okay, so what you want to do is write this as 2x times 2x plus 1 to the minus half. And then you can treat this as like u times v. Right? So how many of you set it up like that where you're doing a product rule? Hopefully. Okay. So you're going to have this. The only one that's going to be difficult is when you get to v prime. Leave yourself a little more space. So this is u prime v and v prime u. Okay, so u prime is just 2. That's easy. V is just that. V prime requires the chain rule. So let's look at v prime. So here in green is my v, and I'm going to be bringing down the negative half. I'm going to be taking away 1, and that's going to look like this. Bring down the negative half. Rewrite the argument, take away a power, and then multiply by the derivative of the 2x plus 1. So what's the derivative of my 2x plus 1? 2. So I could put that here. And then I have just 2x right there. Yes? And I meant 2x plus 1. Thank you. All right. Okay, so you can rewrite it like this. We have here basically a half, and there's a 2, and there's a 2x, so that's all just minus 2x plus 1. So you guys are good at rewriting all this stuff. But I would suggest that before we do the second derivative, that we factor it. Okay, so this is a trick actually that I learned from a student. You can pursue this if you want. It's just going to end up being a little messy. And I definitely would not go the radical route. Like, don't put the radicals in. So what I would do is pull out the lesser of the two common items. So like, you have a 2x plus 1, and then there's a 1 that has a negative half power, and there's a 2x plus 1 that has a negative 3 half power. Pick the one that's lesser, so that would be the negative 3 halves, and factor it out of everything. So watch what happens. I'm going to take out 2x plus 1 to the negative 3 halves. You might say, well, that first term, Mr. Short, doesn't have a 2x plus 1 to the minus 3 halves. Oh, I can also pull out a 2, can't I? See the red 2 here? Let's pull that out too. Okay. You might say, well, how can you pull that out? It's not even in the first term. Well, when I pull out something with a negative 3 halves power from something that has a negative 1 half power, what I have to do to this negative half is add 3 halves. So if I'm going to factor something out, it's a division. So what is negative 1 half divided, or 2x plus 1 to the negative half divided by 2x plus 1 to the negative 3 halves? It turns out you just take this and add that. So this would give you 2x plus 1 right here. If you don't believe me, you can take a look at it later and convince yourself. But this is just 2x plus 1 to the first power. Beautiful. As for this other part, there's just simply an x. That's from this part here.
So you add it or subtract it?
What you do is you take this negative half and you add this. And that gives you the power here, 1. You're pulling out a negative 3 halves power, which means you're dividing by 2x plus 1 to the negative 3 halves. So this becomes 2x plus 1 to the first. I know it's a little hard to see, but it works. And that makes this problem a lot easier to pursue for our second derivative. Okay, so this now just looks like this. 2 times 2x plus 1 to the negative 3 halves. And this part, well, this part is just simply x plus 1. This is no more difficult than the original problem we started with. So doing the second derivative will feel just like doing the first derivative now. Okay, so that was a really weird factoring step, but it works. All right, let's go on. It's time to do y double prime. Y double prime, this is now our u. and this is now our v. I think it's u prime that's going to give us some trouble, so that's going to involve the chain rule. As for that 2 in front, I can just leave that way out front. Let's just put that right here. You shall stay there too. Don't move. Okay. All right, so I'm going to do u prime v, v prime u. Okay, u prime, that's this object here, derivative. Bring the negative 3/2 down, take away a power, and multiply by the derivative of the inside. So it's going to be negative 3/2. It's going to be 2x plus 1 to the minus 5/2, and multiply by 2, because that's the derivative of the inside. Then we just copy x plus 1 here. V prime is simply 1. That's simple enough. And u is copy and paste from up above. Okay, so let's go ahead and clean this up a little bit. So we have y double prime equals negative 6 times x plus 1 times 2x plus 1 to the minus 5/2. And then we have plus 2 times 2x plus 1 to the negative 3/2. I went ahead and redistributed the 2 and tried to make it look kind of nicer. You can figure that out later. But if we were going to do a third derivative, I would then factor out which of these would I factor out? A or B? A, right, because it has the lesser power. So I would factor out that A term, and then that would make it more presentable to go on and do a third derivative. So you might say, well, we're not going to ever do derivatives that many times. Yeah, you kind of are. Because when you do Taylor polynomials, you do the derivative not once, twice, or 3 times, but 4, 5, 6, 7 times sometimes. So it's going to be really helpful to keep factoring it, take the derivative. Factor it, take the derivative. That way it'll always feel like a single product rule. Yes?
What would the second term be if you did factor out the 2x plus 1 to the negative?
That would become a 2x plus 1 regular. Yeah. You would add 5/2 to this, and it would just become 2x plus 1.
Because you're subtracting negative 5/2?
Because you're subtracting negative 5/2, that's right. I know it's a little bit awkward, but it beats the option of doing the radicals on the bottom. That's awful. Rationalizing all the time. So it's a really neat little trick. If you want to try the third derivative tonight, you can, and then if you want to check your answer, I don't know if you guys have ever used Wolfram Alpha, but it is extremely powerful. Let me just show it to you real quick. On here. Okay, so we don't really have time to do like a Q&A because they gave us a short period again today. So if you had questions on the page, what was it, 153, part A, those are chain rule problems, and you can come see me after class, show me what you got done, and then if you need an extra night to tidy up the last few, that's fine. But we're moving on, just doing more chain rule problems tonight. So, okay, so this is what I've got on the board here is something that AP Test loves to do. They love to give you just a table full of numbers and ask you to find the derivative and f of g and all this stuff. So why don't you take a minute and copy down this table so we can look at these 4 examples together. That's right. Okay, so on this stuff, what you need to do is write out the chain rule or the product rule or the quotient rule first, and then you're going to take the numbers and plug them in, okay? So let's look at part A here. Let's see, so part A is asking us to find h1 prime of x first. So we're going to find h1 prime of x and plug in 3. Okay, that's what it means to find h1 prime of 3. So we're going to take h1 prime of x, get the derivative figured out, then we'll plug in 3. All right, so that's the order of our strategy. Okay, so h1 is defined as f of x times g of x. So finding the derivative won't be very hard. That just means you're going to be taking the product rule. So h1 prime of x would be the derivative of the first function times the second function plus the derivative of the second function times the first function. Okay? Now we'll plug in 3 into this expression. So it's h1 prime of 3 equals f prime at 3 times g of 3 plus g prime at 3 times f at 3. See? Now this is a simple problem. It's very simple. Your table provides you with these 4 numbers. So let's make sure we can all read the table properly. We'll just do shout-out answers here. What is f prime of 3 according to the table? 1/2, right. And what is g of 3? Look in the third column, right? The fourth column, technically. It's right there, right? 2, okay. Okay, what is g prime of 3? It's right there, right? X is 3. G prime of 3 is 3/2. And f of 3, what's f of 3?
1.
Isn't that right there? 1? Okay. So this is not a hard problem at all. It's all numeric, but you do have to know the product rule, right? All right, so this just comes out to be whatever it is. 1 plus 3/2 is 5/2. Right? Okay, so for part 2, you're doing f of x over g of x. So you'd be using the quotient rule instead. Okay? So I'm just going to, instead of scrolling down, I'm going to erase. Can I erase this first example? Everyone got it? Okay. So this time it's going to be division. They're calling the function h2. This time we're going to be plugging in different number. What do they want us to plug in? Plug in 1. Right. Part 2 says find h2 prime of 1. Okay? So we'll be using probably the quotient rule for this. So h2 prime of x is going to be low d high minus high d low all over low squared. Then we'll plug in 1 because we're doing h2 prime at 1. So it's g of 1 times f prime at 1 minus f of 1 times g prime at 1 all over g of 1 squared. See? But those are just numbers. Okay, g of 1 is in the table, it's 3. F prime of 1 is negative 2. F of 1 is 4. G prime of 1 is negative 2. And g of 1 is that 3 again. So the answer comes out to negative 6 plus 8 all over 9, so that's 2/9. Interesting problems, not very hard, but you have to know what to do. Okay, what's this next one? h3 of x. Can I erase number 2, part B here? Everybody got it? Okay, so this time the function's name is h3. We're plugging in 2 because they asked for h3 prime of 2. But the function is f of x quantity squared. So this would be treated with either the product rule, if you want to think of it as f of x times f of x, or the chain rule, if you want to think of it as a function plugged into the x squared function, you know. Okay, so I'm going to actually treat it with the chain rule. I'm going to bring that 2 down, take away a power, and then multiply by the derivative of the inside. Okay, so h3 prime of x is, let's bring the 2 down to the front, and then we have just f of x to the first power, right, times the derivative of the inside. What is the derivative? What is the inside function? F of x. So what's the derivative of that? F prime of x. Right. Okay, so now we plug in the number. For this problem, we're doing at 2. So it's 2 times f of 2 times f prime of 2. Interesting. And this is just 2 times, and then f of 2 is 2, I'm sorry, and f prime of 2 is negative 3 halves. So this just comes out to be negative 6. Okay, one more, and that is f composed g. That's our h4 function. Can I erase? Got it? Alrighty. So now we're doing h4, plugging in 1. h4, plugging in 1. Okay, so h4 prime of x, since the function h4 of x is f of g of x, we just treat the chain rule. We're going to write down the chain rule basically in the Lagrange notation, so the prime notation. So it's going to be outer function's derivative first, but don't change the function argument. Like, don't change the input, right? You just take the derivative of the outer function. Then you multiply by the derivative of the inner function. Okay, now let me just say something about this little of x notation. Some people get a little lazy and they stop writing the little parentheses x. Most of the time that's perfectly fine. Our book does it too. They'll write f prime when they mean f prime of x. They'll write g prime when they mean g prime of x. They'll write f prime of g when they mean f prime of g of x. Okay, but if you stop writing little of x's on these problems, you can get a little lost. Okay, so I'm always putting the little parentheses x, because now I plan to plug in 1, like they said, and mine is ready to go. This is completely ready for calculation. It's f prime of g of 1 times g prime of 1. See? Okay, so I've got to go to the table and find g of 1 first. So what's that? Negative, wait, g of 1 is what? 3. Yeah, make sure you're looking in the right spot there. G of 1 is 3. G prime of 1 is negative 2. Okay. And then now I got to go to the table and find f prime of 3. So that's 1/2. So this comes out to negative 1 in the end. Interesting style of question. I never saw it in high school because I wasn't in an AP class. I just took a calculus class, But if I had taken the AP test that year and just seen the question for the first time on the, in May, I would have been like, what are we doing here? Like what's the point of this? And then I would have missed it probably, because I just wouldn't have. I've never seen a style question like that. I've never seen it since, and I've never seen it. I've only seen it in the context of the AP test, But it does test your understanding. It really does. So it's a great question.
Would that be an FRQ?
No, this would probably be a multiple choice problem. Yeah. And it would only give you one part. But I wanted to show you how you can use all your rules there. Okay, we always do this, right? We always talk about the equation of the tangent line. The functions just get more and more complicated as we go. Okay? So I just want to remind you that when you see this phrase, at x equals pi over 3, that means a is pi over 3. That's what it means. So you can use that formula that I gave you. Y equals f prime of a times x minus a plus f of a. We love formulas, right? We're trying to find the tangent line equation at pi over 3. So it's f prime of pi over 3 times x minus pi over 3 plus f of pi over 3. And now we have to find f of pi over 3 and also f prime of pi over 3. Okay, so they gave us f of x is given, it's cosine of, and if you don't mind, I'm going to write it as 1/3 x instead of x over 3. I like that a little better. They did not give us the derivative. Why should they? But I definitely know what this last part of the problem is. It says f of pi over 3. That's just cosine of pi over 9. Okay? Cos pi over 9. And since that's not a unit circle angle, I think I'll just leave it like that. At the end, maybe I'll go back and get my calculator out and see what that is. Okay? Then this part, as you know, is just part of the equation, so just leave that there. So this brings up one more question. What is f prime of pi over 3? Well, you need to find f prime of x, right? Okay, so now let's find a little detour problem. We've got to find f prime of x and plug in pi over 3, right? Okay, so you tell me, what is the derivative of cosine of 1/3 x? First and foremost, it's a cosine, so it's going to have derivative what? Negative sine. We don't change the angle, but we also multiply by the derivative of the inside, right? So what's the derivative of the inside? 1/3 is correct. So I'll just put that in the front. Nobody puts their amplitude at the back, right? Plus I'm running out of room. So it's, for my f prime of pi over 3, it's negative 1/3 sine pi over 9. It's just a number. I don't know what it is, but that's my slope. Okay, if you don't mind, I'm done with that one. I guess we could get the decimals, but I'm not that interested. My guess is on the AP test, even if this was a free response, they'd let you leave it like that. They're supposed to take any answers that are numerically equivalent. So if you go decimal or leave it like this, it should be okay, as long as you constructed the formula properly. So if I was graphing it, I might change my mind. I'd like to see the decimals or something. Okay, can we move on? Is this a new idea? What I just did, is that a new idea? No, it's an old idea, but the chain rule popped up right here with that 1/3, so that's why I did it. And we will do it over and over again all year long. Yeah, Hunter has a question, we'll move on.
Okay, so the x in the equation, what does that end up being? Is that just the equation of the function?
Well, this is a line with slope m, and it passes through the point pi over 3, comma, cos pi over 9.
Okay, never mind.
So that x is supposed to be there. It's actually the equation of a line. It should have a y in it and an x in it. Otherwise, it's not the equation of a line, typically, right? Okay, so let's go on to parametrics. This is a really big topic in chapter 10, but they do introduce this a little bit early. And if you were in AB, you did not see this, I don't think. I don't know that I taught you this formula. It's not a very hard formula at all. It's actually really, really simple. Parametric functions are when, instead of telling you that, you know, the formula is x squared plus y squared equals 1, instead I say something like this. X is cosine t, and y is sine t. This is the equation x squared plus y squared equals 1. It's written a little differently. Isn't it true that if I take this and square it, and take this and square it, and add these, I get x squared plus y squared equals 1? Isn't that true? Because I'm going to get cosine squared plus sine squared, which is 1. Okay, so this is just a parametric version of a traditional function. And a lot of functions can be written this way. Like, for example, I could write a parabola like this. I could say x is t, and y is t squared. This is the same as y equals x squared. Right? Because if x is t, then I can come over here and change this to an x. See? So by substitution, when you're given parametrics, like let's say these two, x equals t and x equals t squared, if you're given that, you can use substitution to put it together and form a y versus x formula. Okay? So parametrics is something you did in pre-calc. We're not trying to learn parametrics. I'm not trying to have you graph parametrics right now. We're not trying to take two parametrics equations and try to form an xy equation out of it. Okay? None of that. What we're trying to do is follow this little formula here. This is how you find the derivative of a function that is defined parametrically. So, let's just follow the rules. There are three derivatives going on. There's the derivative we wish to find, dy dx, and there is a dy dt and a dx dt. Okay? So, they gave us x as a function of t and y as a function of t. So, if I want to find dy dx, what I'm going to do is take the derivative of y, that's 3 sec t, for my numerator, and the derivative of x, that's the 2 tan t, for my denominator. Both these derivatives are pretty simple. We know that we can just keep this 3 here. If derivative of 3 times something is just 3 times the derivative of something. What's the derivative of secant? Hopefully you have that kind of memorized now. Yeah, that's the one where you go to the beach. So that's sec tan. You want to write sec t tan t. Okay. On the bottom, let's just leave that 2 there. What's the derivative of tan? Secant squared. And this actually cleans up a little bit. And I'll skip the steps because I'm running out of time. But this comes out to 3/2 sine t is all it is. If you write your tan as sine over cosine, and you write your secant t as 1 over cosine. Okay, so there it is. All right, so what's going on at pi over 4? If t is pi over 4, right, x of t, which is 2 times tan of t, would be 2 times tan of pi over 4, also known as 2. And y of pi over 4 would be 3 times secant of pi over 4, namely 3 rad 2. And dy dx, when the t is pi over 4, is going to be 3/2 times sine of pi over 4. In other words, 3 root 2 over 4. So what does this all mean? I got the first two numbers by plugging them into the given equations, plugging pi over 4 into the given equations. And I got this last number by plugging the pi over 4 into my derivative that I found. What does this all mean? This means that the graph of the function passes through the point 2 comma 3 rad 2, and it has slope 3 root 2 over 4. That's all it means. I've got an x, I've got a y, and I've got a slope. So here's the equation of your tangent line. Slope times x minus the x coordinate of the point it passes through plus the y coordinate that it passes through. This is the tangent line of a parametrically defined function at a given value parameter. So it feels a little different at first. You've got this pi over 4. You're supposed to plug that into both parametrics that they gave you. That will give you this point. You didn't have to freak out. You also have the derivative, which was defined by doing the two derivatives one on top of the other. And that will give you the slope, 3 root 2 over 4, and then just set up your tangent line formula. Make sure you follow this example closely when you get to the problems. I think it's 41 through 47 odd there. But your homework is on the board off to the left.